Hi all, good morning. Hi Pooja, good morning. Is my screen visible and I'm audible to you? Everyone? Yes? Okay, fine. Okay, so we'll start the class and tell me like how was your exam? Like, was it easy? Was it easy? Okay, fine. So we'll start the class. Okay, so in today's class, we are going to discuss the uh, mock test 2 paper. Okay, yes. So moving to the first question. Yes, for the first question, in the following sequence of reaction, okay, a reaction is given. You have to find out the degree of unsaturation in the product C. Okay, you have to find out the degree of unsaturation. So for it, first you know, like in first you have to solve the reaction sequence. Okay, you have to solve the reaction sequence, and then for the product C, we are going to calculate the degree of unsaturation. Okay, so how will calculate the degree of unsaturation? Can you tell me the formula for degree of unsaturation? Degree of unsaturation? Yes. Can you tell me the formula for degree of unsaturation? Yes. So degree of unsaturation is equal to 2 times of carbon plus 2 plus nitrogen minus number of hydrogen minus number of halogen by 2. So this is the formula to calculate the double bond equivalence or degree of unsaturation. Okay, so first we'll solve the sequence of the reaction. Okay, so what is given over here is like you have COO C2H5, you have an ester group. Okay, and you can see like here too you have an ester group, and here you have, like if I take this as alpha carbon, how many alpha hydrogen you have? Sorry, this is the functional group. This is the functional group, and the carbon attached to it is your alpha. This is your alpha carbon. Okay, so now I take like this ester group. Now here I have like 1, 2, 3, 4. Okay, so now there is no alpha hydrogen over here. No alpha hydrogen over here. Okay, now looking into the reaction, you are treating it with like C2H5ONA. Now, what does the C2H5ONA will do? Like it will give C2H5O minus and Na plus, right? It will decompose to give C2H5O minus and Na plus. Now, this C2H5OH, it needs hydrogen. It needs hydrogen. And we know that. And we know that like this ester group is, whether it is an electron releasing group or an electron withdrawing group. It is electron releasing or electron withdrawing group. The carbonyl group is, yes, carbonyl group is like electron withdrawing or electron releasing group. It is an electron withdrawing group. Yes. So what it will do? It will withdraw the electron towards itself. It will withdraw the electron towards itself. So I can say that this hydrogen is more acidic. Yes. So this hydrogen out. So C2H5ONA, what it will do is like it will take up the hydrogen. It will take up the hydrogen as C2H5OH. OH. Okay. Yes. So now there is no alpha hydrogen over here. That is why I have not taken hydrogen from this carbon. Okay. Only here I have hydrogen. So I have taken it out. So what charge does this carbon will have? It will have a negative charge. It will have a negative charge. Now I have Na plus. I have Na plus. So what this will do is like you have COOC2H5. Okay. So this OC2H5. Now this carbonyl is like an electron withdrawing group. It will withdraw the electron. So OC2H5 will take up Na and it will go, it as like C2H5ON. It will move as C2H5ONA. Now, what will be the charge on this carbon? It will be positive. Now, this positive and this negative will combine to form a bond. Else, I can say that the electron over here, okay, will move to make a bond between these two carbons. Okay, so clear with the step. I'll write the product now. So therefore, you'll be getting C double bond I have over here, which has a positive charge. And here I have like CH2, CH. Here I have a negative charge and C double bond O C2H. You have this group. Okay. So what is the charge on the carbonyl carbon is positive, and here I have a negative charge. So one hydrogen is removed. So I have like only one hydrogen. Yes. Now these two will combine. These two will combine. Yes. So therefore, the thing will be like C. Can I make a 5-member ring? See, this is a 5-member ring. 3, 4, 5. Okay, I have a 5-member ring. CO, CO, C2, H. And I have a double bond over here. Okay, so clear with the step, everyone? Pooja, are you clear? So this is your A. This is your A. Okay, so clear with the step, everyone? Yes, fine. Now moving to the second step. Now what you have is like hydrolysis. You are doing acid hydrolysis. Okay. So you have like OC2H5. When you do acid hydrolysis, you'll be getting an alcohol, right? You'll be getting an, okay. So alcohol will move out and here you'll be getting an acid. Yes, we know that ester on hydrolysis, what is the product you'll be getting? You'll be getting an acid and alcohol. You'll be getting an acid and alcohol. Yes. So you'll be getting an acid, like I'll write over here. C. Here you have a 5-member ring. Okay. And here I have COOH. COOH. Okay. So what is this compound in general is known as, you have a COOH and you have an acid. Okay. So you have like acid group and a keto group. So what this known as, now see, look over the position of this one is alpha carbon, functional group attached to carbon for COH, and this is your beta carbon. Can I tell this like beta keto acid? It is a beta keto acid, which is your product. Now I got B. Now you're heating this one, you'll be getting. What happens when you heat a beta keto acid? What happens when you heat a beta keto acid? Beta keto acid, what gas will evolve? Can you guess? Like what gas will evolve when you heat a beta keto acid? Yes, Pooja and Kush, tell me. I have given you the clue, like a gas will evolve. Okay, what gas will evolve over here? Like you have COOH, you have COH, so therefore CO2 gas will get evolved. Okay, so what product you will be getting? You will be getting a 6-membered ring attached to a 5-membered ring keto group. Okay, and here the CO2 is removed, so you have only hydrogen. So this is your product C. This is your product C. Okay, now can you calculate the double bond equivalence? Double bond equivalence is 2 times of carbon plus 2 plus nitrogen minus H minus X by 2. You can use this formula or using the compound itself you can tell. Okay, so what is like double bond equivalence? It will give you the degree of unsaturation. So I'll make a bond over here. Okay, so how many? The double bond equivalence will be equal to, double bond equivalence will be equal to 1 for a double bond when you have a double bond, and it will be equal to 1 if you have a ring. So here, how many double bond you have? Like in the 6-member ring, I have like 3 double bond, and I have a double bond in the carbonyl group. And how many ring I have? Like 1 and 2 rings. Okay, 1 6-member ring, 1 5-member ring. So totally the double bond equivalence will be equal to 6. Else what you can do? You can use this formula. Okay, I'll use this formula and so see. So how many carbon you have? Like 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, you have 9 carbon. So double bond equivalence or the degree of unsaturation is equal to 2 into 9 less 2. You don't have any nitrogen, you don't have any halogen, you have hydrogen. So how many hydrogen? 1, 2, 3, 4. Here you don't have hydrogen. And then 5, 6, 7, 8. You have like 8 hydrogen. So minus 8 by 2. So 18 plus 2 is 20 minus 8 is 12 by 2, which is equal to 6. Is equal to 6. So you can do the degree of unsaturation either using the formula or simply counting the number of rings and the double bond. Okay. Clear with this equation and clear with like how to solve this question? Everyone? Are you all clear? Shall I move to the next question? Yes. Everyone clear? Pooja and Kush? Yes, fine. Moving to the second question. Moving to the second question. Okay. See, look over the second question. The relative rate of abstraction per hydrogen atom of tertiary hydrogen, secondary hydrogen, and primary hydrogen of alkane during photochlorination is 5.0, 3.8, and 1. Determine the percentage of the major product of chlorination of 2,2 dimethylbutane is the question. Okay. So now to understand the question first, what they have given is the relative rate. So what is meant by the relative rate? The relative speed of abstraction per hydrogen atom. That is, when you do the chlorination reaction, okay, when you do chlorination reaction, so you have a alkane, okay, you have like 2,2 dimethylbutane. When it undergoes chlorination, what will be the product you'll be getting? What is the product you'll be getting? Like alkane plus halogen will give you. What is the product you'll be getting? You'll be getting an alkyl halide and HCl will be removed. Okay. So hydrogen, it moves out from alkane. So that is what they have given like abstraction per hydrogen atom. So that is the removal of hydrogen atom from the alkane speed is 5.0 is to 3.8 is to 1. So why there are like 3? You have it for the tertiary hydrogen, secondary hydrogen, and primary hydrogen. Okay. So you have to determine the percentage of the major product for the chlorination of 2,2 dimethylbutane. You have to calculate the percentage. Okay. So how to do the calculation? Like percentage is equal to, first you want to know the number of parts. Okay. Number of parts of hydrogen in the major product divided by the total number of parts into 100. Okay, total number into 100. Now, you don't know, like in the question, they have not given the number of parts. They have given you the speed they have given. So, using the speed, you have to calculate the number of parts. So, how to do it? Like number of parts is equal to, the relative speed is given. So, the relative speed, that is relative rate, into the number of hydrogen, that is probability. Probability is number of hydrogen. So when you do this, you'll get the number of parts, you'll get the total number of parts. Then substituting in the formula, getting the percentage. So first we will write the reaction so that we know that what would be the major product. Okay. So first I'm writing the compound 2,2 dimethylbutane. So everyone write the compound 2,2 dimethylbutane in your notebook. Okay, so 2,2 dimethylbutane. So this is your 2,2 dimethyl butane. Yes, everyone got this one? Have you written? Is everyone writing in your notebook? Yes? Fine. So now this is 2,2 dimethyl butane. You're doing chlorination. Now, how to find out the number of products, the number of monochlorinated products, okay? When you do the chlorination, how will you find out the monochlorination products, number of monochlorination products? Can anyone tell me? Or this reaction gives how many products? Or tell me like this reaction gives how many products? Do you know to calculate the number of products? Do you know to calculate the number of products? You may answer. Do you know to calculate the number of products? Yes. Tell me like how many products you get in this reaction? Okay, I'll tell you. Like to calculate the number of products, you should know that how many different hydrogen environment are there. Okay. So number of chlorinated, number of monochlorinated products is equal to number of different environment hydrogen in the given compound. Okay, number of different environment hydrogen. Now, what is meant by the number of different environment hydrogen? You have to check like each and every alkyl, like that is the carbon group. Okay, and find like the hydrogen is attached to the same type of thing. Okay, then it is said to be under the same environment. For instance, okay, you take the CH3, it is attached to carbon. Okay, this CH3 is attached to carbon. This CH3 is also attached to carbon. So all the three CH3 are attached to carbon. So the hydrogens of these three CH3 are going to be in the same environment. So I am marking it as A. Okay, it is attached to C. It is attached to C. It is attached to C. Now this carbon doesn't have any hydrogen, so I'm leaving it. Moving to this carbon. Okay, so it is attached to carbon on one side and CH3 on other side. Okay, so is the environment say like A? No, okay, the environment is different. In A, CH3 is attached to carbon. Here it is attached to carbon and CH3, which is different, okay. So this environment is different, so I'm marking it as B. Now moving to this carbon. Okay, so now is the environment same like A or B? No, it is totally different. This CH3 is attached to CH2, which is different. So making it as now, okay, you know like how to find out the different environments. Are you clear? Like how to find out the different environments? Everyone clear? Clear with how to find out the different environments? Yes. So look over the neighboring atom. Okay. If the atom is same, like when I take the CH3 is attached to carbon, carbon, carbon. So the neighbor is same. So therefore, I'm telling that these three are of same type. Here the neighbor is different and here the neighbor is different. So there are like three different environments. So how many monochlorinated products will be getting? How many monochlorinated products will be getting? It is equal to the number of different environment hydrogen. So how many different environment hydrogen you have? Like 3. So the number of monochlorinated product will be equal to, what will be the number of monochlorinated products? Everyone? Yes, it will be equal to. Okay, so how to write the product? Like I have written 3 different environments, right? So remove hydrogen from each and every environment and replace with fluorine. Okay, you're going to substitute hydrogen with fluorine. You'll be getting 3 different products. So here I have like 3 same environments. So you can do it for any one of the CH3. It is not like mandatory. You have to do only for the specific CH3. Since the environment is same, you can do it for any one of the CH3. So I'm taking this CH3 and substituting it with Cl. You can do it for this and as well as the one which is below. Okay. So now what product you will be getting is, you will be getting, I'll use different color. So it'll be get like CH2Cl. Okay, all the others remain going. It's going to remain same. So carbon CH3, CH3, CH2, CH. So this is one of the products. What would be the second product? You are going to replace the B environment hydrogen. Okay. So replacing the B environment hydrogen. So I'll be getting like CH3 carbon. And here you have to replace one hydrogen with Cl and the remaining is to be CH3. Now, can you write the third one? Can you write the third product? Yes. Write down in your notebook. Write down in your notebook. So you'll be getting, it is going to remain same. And here hydrogen is to be replaced with fluorine. Yes, have you all got the three products? Okay, one is for A environment, the other one is for B environment, and the other one is for the C environment. Okay, have you all got the products? Yes. Yes, clear with the products, everyone? Now to find out the major products. Clear with the products, right? How to find out the different environment and how to write the products. Are you all clear? Are you all clear? Everyone? Yes. So now moving to how to find out the major product. Now tell me like which one would be the major product? Which one would be the major product? So this reaction, will it follow the ionic mechanism or free radical mechanism? What type of mechanism will it follow? You have Cl2 and the chlorination, it takes place in presence of light. Okay, in presence of light. Okay, so what type of mechanism will it follow? Free radical or ionic mechanism? You have light, you have like same atom. So homolytic fission happens, obviously free radical mechanism. Okay, so for a free radical, which free radical is stable? Like give me the stability of free radical. Stability of free radical. Free radical is going to be stable. What is the order of stability of free radical? Yes, in chat box. What is the order of stability free radical? Very good. It is tertiary, secondary, and primary. Okay, so this is the order. Now tell me like which product will be the major product among 1, 2, and 3? You know the order. Now you can predict, right? Which one would be the major product among 1, 2, and 3? Which would be the major product among 1, 2, and 3? Okay, so tell me like what type of halide it is? What type of halide it is? Like it is attached to a tertiary carbon. So I can say like this is attached to a tertiary free radical. Here it is attached to a secondary free radical and here it is attached to a primary free radical. So which is going to be like stable now? Tell me, like you know the order, tertiary, secondary, primary. So therefore, this would be your major product. Got it? This would be your major product. Yes? Got it, everyone? Yes. So now this is your major product. Now what you have to do is determine the percentage for of 2,2 dimethyl butane. Okay. So now for it, what I have told you, you have to calculate the number of parts. You have to calculate the number of which is the probability of hydrogen. And here for 3-degree hydrogen, it is 5. So how many 3-degree hydrogen you have? Like when I take the environment A, okay? So here only you are getting the 3-degree major product. So how many 3-degree you have? Like 3 is 9. So 9 into what is the relative rate is 5. Okay, so the relative rate is 5. So therefore, okay. So what I have to do over here is like you have to take the 3 degree, 2 degree, and 1 degree is given. 1 degree is given. Like how many 3 degree hydrogen you have? How many 3 degree hydrogen you have? You don't have any 3 degree hydrogen over here, right? And how many 2 degree hydrogen you have? How many 2 degree hydrogen you have? Yes, so when you take this one, when you take this one, okay? So here you two, it is done from H2. So many hydrogen you have like hydrogen. And the rate over here is like 3.8. Just okay. So if it is like 3.8, then what is it getting? It is 7.6. You are getting it at 7.6. Now moving to this part. Moving to this part. Okay. So here you have like CH2Cl. You have like CH2Cl. And what is the degree over here? It is like it's attached to like 1 degree. So therefore 1 into how many carbon, how many hydrogen you have? Like CH3. You have like 3. 1 into 3 is going to be 3. And this is also CH3, 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 which is also 1 degree. And it is like 9. Okay, so 1 into 9 is equal to 9. Now, what is the total part? It is 7 plus 7.6. It is 9 plus 7.6. So 9, 11. So this one will give you the total number of parts. Okay, everyone, how I did this ratio and I have multiplied it. Got it, everyone? Got it, everyone? Any doubt? This calculating number of parts. Calculating the number of parts. Do you have any doubt? Are you all clear of calculation of numbers? Yes? Okay, fine. So now you're having like, you just add these together. Okay, so 9, 12, 12 plus 7.6 is 19.6 is the total number of parts. And which is your major product over here? Which is the major product over here? This is major product. What is the number of parts? 9. So I'll write it as like 9 by 19.6 and you'll get the answer as 45.92%. Okay. So therefore, this would be your answer. This would be your answer. Everyone got the answer? So this is the percentage of major products. Do you have any doubt with this question, everyone? Everyone clear with the question? Any doubt with the question? Shall I want to repeat it again? Shall I want to repeat it again? Any doubts? Is my screen visible to everyone? Okay, fine. Are you clear? Clear with the question? Okay. Moving to the question is the pKb value of ammonium hydroxide is 2. And the solution of ammonium hydroxide is titrated with HCl. The pH of the solution at the point where half of the ammonium hydroxide has been neutralized. They have given the value. Okay, you have to calculate the pH. And the solution of ammonium hydroxide is treated with HCl. Okay, so when you treat like ammonium hydroxide with HCl, okay, so HCl is an acid and ammonium hydroxide is the base. So type of reaction it is What type of reaction it is? What type of reaction it is? Acid plus base gives, what will be getting? NH4Cl and water. So you'll be getting salt and water. So can you tell me like what type of reaction it is? It is neutralization reaction. Neutralization reaction. Yes. It is neutralization reaction. So when you write a neutralization reaction, okay, it is in equilibrium. So at neutralization point, okay, so the concentration of the base NH4OH will be equal to the concentration of the salt. Or I can tell that the concentration of NH4 or concentration of OH minus is equal to the concentration of NH4. Okay, so now you have base, you have the salt, and the pKb values given. You have to calculate pH. So what equation you'll be using to solve this question? What equation you'll be using to solve this question? What equation you'll be using to solve the question? What equation you'll be using to solve the question? Yes. Can I use the Henderson equation? Can I use the Henderson equation over here? Yes. So using the Henderson equation, so PKB is equal to COH plus log of concentration of salt by concentration of the base. Concentration of salt by concentration of the base. Yes, fine. Now, pKb value is given as 4. COH I'm going to calculate plus log of. What value you should write over here? We know that the concentration of base and concentration of salt is equal at neutralization point. So the value will cancel out to give 1. Shall I write it as 1? Because the concentration is 3. Okay, so log 1. So therefore, COH is equal to 4. Now tell me like what would be pH value? What would be the pH value? You'll get the answer. What would be the pH value? Yes, very good. It is 10. So 14 minus 4 is equal to 10. So your answer will be 10. Got this question, everyone? It is very simple question. Yes? Shall I move to the next question? Shall I move to the next question? Yes, fine. Next question is the pKa value for 3 ionized groups of lysine, okay, which is an amino acid, are given. The isoelectric point of lysine. What would be the isoelectric point of lysine? Okay, so here to calculate the point if pK values are given. Okay, so first you have to look into the amino acid. Okay, so you have to look into the amino acid. So if the amino acid has any side chain, you have to look like the amino acid have the side chain or not. Okay, if it do not have side chain, if it do not have side chain, or I can simply say it as no side chain, no. Where there be like, tell me an amino acid where there is like no R group, no R group. No R group. Okay. Write the general formula of amino acid. It is R. Yes. Carbon, COH, NH2 hydrogen. This is the amino acid. So here, if there is like R, you have to check out like whether you have the R group or not. If there is no R group, then it will be like CH2, COOH, NH2. Yes, COOH, NH2. So it is NH2, CH2, COOH. What amino acid it is? What amino acid it is? It is the first member amino acid, right? What amino acid it is? Like you don't have the R group. You have, instead of R group, you have a hydrogen atom. Can I tell it as like glycine? Yes, glycine. That is why glycine is a chiral. Where all the other amino acids are chiral because you have a R group over here. So no side chain is glycine. If you don't have side chain, or you can do it like amino acids has side chain. So all the other amino acids have the side chain. Okay, so for glycine alone, what you have to do is it do not ionizable. The average of, okay, you have to do the average of alpha NH3 is alpha COOH. Okay, you have average total, right? Total will give you the average. Okay. Now, if I had the side chain, you have to be careful like whether the amino acid is acidic or basic. Okay. If you have the side chain, again, I'm going to do it into two. Like if you have the acidic or basic It depends on the number of COH H3 you have. Okay. So if the number of CH3 is, if the number of COH is high, then the amino acid is going to be acidic. Okay. So number of COH is greater than number of NH3, where the reverse is applicable for the base. Okay. So now can you tell me like the given lysine amino acid is acidic or basic? Just look over the structure and tell me like whether it is acidic or basic. It is basic. Yes, you have like 2 NH3 group. So therefore it is basic. Okay. If it is acidic, then take the average of COOH alone. If it is basic, then you take the average of NH3 alone. So what you have to take? The average of NH3 alone over here. So I can tell that pH is equal to, okay, pH is equal to, that is your isoelectric point, is equal to, what is given like Y and Z alone, you should leave X, okay. So X value is 2.2, I'm leaving it, I'm taking only Y and Z. So 9.0 plus 11.5 by 2 is going to be 10.2. So this is your answer. That's it. Okay. So your isoelectric point of lysine is 10.2. Got it, everyone? So this is how you have to solve this question, this type of question. So if glycine is given, you have to take the average of all the things. Okay. If it is like glycine, if it doesn't have any side chain, you have to take the average of NH3 as well as UH. If it is like acidic, the one which is more you have to take. Here NH3 is more, so I'm taking the average. If you have like COH more, you have to take the average of that to get the isoelectric. Got it, everyone? Got it? Yes. Any doubt with this question? Do you have any? Yeah. So moving to the next question. If you have the neutral amino acid, then you have to take the average of like this of both. Okay, if you have like, then you have to take both. Got it? Yes. Okay, so moving to this question. The specific rotation of 2-butanol is 12.5 degree. Sample butanol containing both forms to have a specific rotation value of minus 2.8 degree. The percentage of plus or minus 1 is okay, sorry, plus 2 butanol alone is given in the sample list. Okay, so specific rotation of 2 butanol is 12.5 degree. A sample of 2 butanol containing both enantiomers like plus and minus. The specific rotation is minus 2.8 degree. You have to calculate the percentage of plus butanol in the sample. Okay. So have you solved this question? Like, do anyone got the answer? Like, do anyone solve this question? Attempted this question? Did you do this question? You have to calculate the percentage of plus butanol. You have to calculate the percentage of plus butanol. Okay. So how will you calculate the percentage of plus butanol? For this, first you have to calculate the optical purity. That is the pure optical component. So what is like optical purity? The given okay the of two into the optical purity. So the optical purity is going to be like minus 22.4% is the optical purity. Okay, now you got the optical purity is minus 22.4 degree. Okay. Now then you have to calculate the amount of racemic mixture. Okay, so this is like for the optical purity of the whole 2 butanol. Now we are going to calculate the amount of racemic mixture. So amount of racemic mixture is equal to so 100, and you have like what is the optical purity is 22.4. So 100 minus 22.4 is going to be like 77.6%. 77.6% amount of racemic mixture. Now racemic mixture will contain like both plus and minus. It will contain like plus and minus. Now I have want the okay, you want the optical purity again. See, okay, so the specific rotation of 2 butanol is plus 12.5 degree. Okay, a sample of 2 butanol containing both enantiomers. So that is the mixture. Plus butanol and minus butanol has the specific rotation value of minus 2.8 degree. Okay, so that is mixture. Like, can I say the enantiomer? Yes, enantiomer. So optical purity is equal to the rotation of enantiomer by the specific rotation of a particular, whether it is D isomer or L isomer. Okay, specific rotation of enantiomer by specific rotation of one isomer alone. Okay, whether it is like D or L, or I'll write it as D or L isomer into 100 will give you the optical purity. Okay, so for the enantiomer, that is the one which contain both the enantiomers was found to be like minus 2.8%. Okay, so minus 2.8 divided by for 1, that is like for D plus alone, it is 12.5. So by 12.5 into 100, you'll get the optical purity. Got it, Ankush now? Yes. So now the amount of racemic mixture is 77.6%. Okay, it is the total amount. Now, we know that in the racemic mixture, you have like, what is racemic mixture? It is 50% of plus and 50% of minus isomer. So, when you want to take the plus isomer alone, because plus isomer alone is asked in the question. So, half of 77.6 plus isomer, because we know that Racemic mixture is 50% plus and 50% minus. Equal amount of plus and minus is racemic mixture. Got it? So 77.6 by 2. Okay, 77.6 by 2. Plus, what is the optical purity you have got? Like 22.4 is the optical purity. So what will be the percentage? It will be like 16. 8.8. So first you have to do it for the minus isomer. Because plus isomer is given in the question. Okay, doing it for the minus isomer, I'll be getting 61.2 percentage. So percentage of plus isomer will be equal to 100 minus 61.2, which is equal to 38.8%. Or it is 0. Is your answer. Got this question, everyone? Any doubt with this question? Moving to the next question. Find the degree of ethyne. Let's observe the molecular mass of the mixture. Okay, they have given the observed molecular mass of the mixture is 39. The observed molecular mass of the mixture is 13. You have to find out the degree of association of ethyne. Okay, so for this, you have to find out the Van't Hoff factor. If you know the Van't Hoff factor, then you can do with the degree of, yes. So now I'll write the equation. C2H2 gives C6H6. So how many C2H2? Like 3 moles of C2H2 will give you C6H6. Okay. So now taking the initial number of moles. So number of moles initially at time t is equal to 0. You'll have like, I'm taking it as like 1 mole. Okay. Will there be like any number of moles of C6H6? No. Now after time t, what it will be like alpha amount has been converted to product. So I'm taking it as like 1 minus alpha. And here it is like alpha by 3 because here 3 moles gives 1 mole, right? So alpha by, okay. So this is after time t, after time t. Now, what is Van't Hoff factor? When the molecular mass is given like normal molar mass by observed molar. Observed molar. Now, tell me like what is the normal? That is normal is nothing but calculated molar mass. What is the calculated molar C2H2? What is the calculated molar ethyne? You just do the molar mass calculation for ethyne. What is the molar mass of ethyne? What is the molar mass of ethyne? Just give me the answers. People, are you there? Are you there? Yes. Get me the answer. What is the molar mass of ethyne? It is 26. Very good. The molar mass of ethyne is 26. So 26. Yes, 26. And the observed molar mass. What is the observed molar mass? Is 39. Is 39. So you will be getting it as like 0.67 is your Van't Hoff factor. 0.67 is your Van't Hoff factor. Okay, so you can do like this, and then you can just equate it to the number of moles given. Okay, so we know that alpha is equal to, here it is like degree of association. For degree of association, what is the formula? Like there are 2 methods to do. I'll teach you both the methods. Okay, which you find easy, you can do it. So I minus 1 by 1 by n minus 1 is the formula. Yes. So what is I? We have calculated it 0.67 minus 1 by 1 by, what is the number of moles of ethyne is given in the question is 3 minus 1. Okay, so you'll be getting it as like 0.5. This is you'll be doing in this method, that is using the Van't Hoff factor. Else what you can do using this thing, okay, using this table, you can do the calculation like what is the molar mass of the mixture? Okay, so molar mass of mixture, nothing but the average molar mass. This is nothing but the average molar mass. So now how will you calculate the average molar mass? What is the formula to calculate the average molar mass? It is the molar mass, okay, of both the reactant and product divided by the total number of moles. Yes. So now here you have like C2H2, you have like 1 minus alpha, and the calculated molar mass of C2H2 is 26. So it is 26 into number of moles plus. What is the molar mass of benzene? What is the molar mass of benzene? Molar mass of benzene is 78 into alpha by 3. Okay. By total number of moles is 1 minus alpha plus alpha by 3. And you have the molar mass of, that is the average molar mass, nothing but the molar mass of the mixture is given as 39. So I'm equating it to 39. So 39 times of 1 minus, okay, just solve this part. What you'll be getting? Minus alpha plus alpha by 3, it will be equal to 2 alpha by 3. Yes, 2 alpha by 3 is equal to 26 minus 26 alpha plus 78 alpha by 3. Just do it like you'll be getting 26. So here you'll be getting like plus 26 alpha. So these two will get cancelled. Yes. So here you'll be getting 13 times. So 1 minus 2 times of alpha by 3. Okay. So here you'll be getting is equal to sorry, here I have taken it as common. You have to just solve this one. Split it and solve. Okay. So one will be 39 minus 26. Okay, 13 minus 26 is going to be like 30. So 2 alpha 3 is equal to 30. I have like one more 39. Yes. So 13. 13 into 2 is going to be 26 alpha. Okay. So 26 alpha alone you want. So alpha will be equal to like 26 by 13. 1 by 2 is equal to 0 points. So you can use like average molar mass, or you can use the Van der factor to solve this question. Got it, everyone? Okay. There are like two methods to solve this question. I have explained like both the methods. Clear? Clear with this question, everyone? Shall I move to the next question? Shall I move to the next question? Yes, fine. So moving to the next question. Okay. So it is from metallurgy, right? Have you gone through this isolation of metals? So in isolation of metals, there are 3 steps to isolate a metal from its ore. Okay, we know that the metals are obtained in the nature in the form of ore. What is meant by ore? It will contain higher amount of percentage of the metal with the other impurities. Okay, so first to do the concentration. Okay, it will extraction of metal. Third step is the isolation. Now talking about the spot flotation, it is one of the method in concentrating the, okay. So it is the method of separating mineral from the ground. So this GAM particle is nothing but the impurity. Impurity means the gram. So in concentration, what you will be just separating the impurity and the mineral or ore separately. So this is the right option. Guys, am I audible? Am I audible to everyone? Am I audible to everyone? Yes, fine. So it is a physical method to separate the ore. Option is right. It is a method to concentrate ore. I have told you, right? It is a concentration of ore. It is all right. And it is a method to do the sulfide ore. Okay, it is the method to concentrate the sulfide ore. And in this method, in which come to the surface. Okay, it will come to the surface as froth. So that is said to be a froth flotation. What is meant by like froth? Froth is nothing but the foam which comes out. Okay, so therefore it comes out at the top layer. It will not go to the bottom. It will not go to the bottom. So like option 1, 2, and 3 are right. A, B, C are. Now moving to the next question. A single electron species having atomic number make a transition from 2 to 1. The photon is absorbed by the excited electron of lithium 2 plus in N1 orbital and further excited to N2 orbital. Okay, N2, sorry, N1 to N2 energy level. You have to find out the value of 2 N1 plus 3 N2 plus 6 Z by 10. Okay, so this can be solved just by using this energy of hydrogen formula. That is like you'll be calculating the wave number, right? Using that formula, you can solve. Okay, so what is the formula is 13.6 Z squared by 1 by N1 square minus 1 by N2 square. So just you're going to equate these two. A single electron species having atomic number 2, Z, make a transition from 2 to 1. So 13.6 into, they have not given the atomic number. It is represented as Z. So I'm making it as Z by what is like N1. N1 is 1 and N2 is 2. So 1 by 1 minus 1 by 4. 2 squared is equal to 13.6 into. Here they have given you it as lithium 2 plus. So what will be like Z value for lithium 2 plus? Get me the Z value for lithium 2 plus. What would be the Z value for lithium 2 plus? Yes, it is equal to 3. Yes, so 3 squared is like 9 by 1 minus. Here they have not given the N1 to N2. You have to find it. You have to find it. Okay. So now I'll cancel these two. I'll cancel these two. And here you'll be getting it as like Z squared into 4 minus 1 is 3 by 4. You'll be getting 3 by 4 is equal to 9 into this one. Okay. So now just solve this 3 times. So I'll be getting it as like Z squared is equal to 12 times of this one. 12 times of 1 by N1 squared minus 1 by N2 squared. Or you can just simplify this one. You just cross multiply and bring it to the other side. Okay. So you can write it as like N1 square minus N2 square by N1 square minus N2 square. Okay. Into. So bring it to the other side. So you'll be getting Z squared into N1 squared into N2 squared by N1 squared minus N2 squared is equal to 2. You got this? You got this? Now you have to like assume and find out n1, n2, and z value. Okay, if you assume like z is equal to 1 and put n1 equal to 1, n2 equal to 2, solve, and you have to check like whether it is equal to 2. And then if it is not equal, change the n values. Okay, so I'm making like n1 equal to 1 to 2. We should do. Again, like n2 is equal to like any values you can put. Again, the transition, like from, you can make it from 1 to 2, and then you can make it like from 2 to 4. You have to make, like, I'm assuming that z is equal to 1, and you have to do the transition. You have to substitute the values and find out like which is equal to 2. Okay, if you solve this, you'll be getting like z is equal to 1, n1 is equal to 3, and n2 is equal to 6. So this is what you'll be getting. Like if you just substitute n1, z is equal to 1, and 3 squared is 9 into 36 by n1 square, sorry, n2 square minus n2 square minus n1 square. So 36 minus 9. Yes. So will it be equal to 12? So therefore, n1 equal to 3, n2 equal to 6, that is equal to 1. Now use this over here. So 2 times of n1, 3, plus 3 into 6 plus 6 by 10. By 10. Okay. So your answer would be equal to like 3 would be your answer. Okay. Just you have to assume and like put one values and see. Okay. So here they have given you like the photon is absorbed by excited electron of lithium 2 plus in n1 orbit and further excited to enter orbit they have given. You have to like put 1 and 2. So 1 squared will be, I'm assuming like z is 1. So 1 into 1 squared is 1 into 2 squared is 4 by 4 minus 2 is 2. So whether 4 by 2 is equal to no. So now this transition will not be possible. Okay, now move to the next transition and look for. Okay, so same way, if like fit and find out when I put like n1 3 and n2 is equal to, then I'm getting the value as 12. Okay, so therefore this one is fixed. You have to assume and find it. Got it, Ankush? Got it, everyone? Like because we don't have like any other things to solve, hence we are finding. Now we do the next question. Okay. The question is a solid B solid Kp of about reaction is 9 atmosphere square at 327 degrees Celsius. Then like 1 mole of B, how many moles of C would be added to drive backward reaction for completion? Okay, so first I'm writing the equation like A gives B plus 2 times C. Now I'm writing the backward reaction. You have to reaction. Initial number of moles is given as 1. Okay, so in the backward reaction, this will be your reactant and this will be your product. The number of moles is 1. And they didn't give you the initial number of C. Now, but the Kp is 9 atmosphere required. So Kp for, here they have given like for atmospheric squared, which is a gas. Yes. So that whole region, you can tell like Kp is equal to concentration of C. Yes, concentration of C because it's only gas. So therefore, Kp value is given as 9. So 9 is equal to concentration of C to the power 2. So what would be the concentration of C? What would be the concentration of C? Now you'll get the concentration of C. Yes. What would be the concentration of C? What would be the concentration of C? Yes, it is going to be like you are taking the square root, it will be equal to 3. It will be equal to 3. Okay. So here 2 times of C they have given. So if I take that it has like A moles, okay, they didn't give you the concentration over here. Okay, sorry, this should be the pressure. So, so 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 concentration is A mode. After the reaction be done, like to be taken up. So A minus it is for the backward reaction. So backward reaction. So A mode formed okay, that is consider like A as a state, it forms like now again. Guys, able to hear me? Is my screen visible to you all? Is my screen visible? Like I'm not getting any response. Is my screen visible? Am I audible? Is my screen not visible? Is it visible now? Can you check? Yes. So now what it will be like A minus 2. Okay, it is giving back A. So therefore it will be like A minus 2. Okay, so got this? Okay, fine. Now write to find out the concentration. So now what is concentration is equal to A by 2. Okay. So now what you have to find out like how many moles of C would be added to drive back the reaction. Okay. So you have to find out the number of moles. Now we know that P is equal to nRT. Just substitute the values given. You'll know the N value. Okay. So P is 3 into volume is like 10 liters is equal to N into what is like gas constant is 0.0821 because here atmosphere liter is given. Okay. Into temperature is 327 degrees Celsius. Convert it into Kelvin. So you'll be getting like 327, sorry, 327 degrees Celsius. So I'll be getting like 600. So if you solve this, you'll be getting the N value. You'll be getting the N value. Okay. So can you solve and find out the N value? Can you give me the N value? So what would be the N value for 16? So 1, 2, 3, 1.6. So N value is equal to 1.6. So 1.6 is your answer. Got it, everyone? Any doubt with this question? Yes, fine. So moving to the next question. Okay, so look over this question, which is a statement. If CaO2 is less stable than MgO2, Ka of fumaric acid is more than Ka of malic acid. LiCl is less soluble in polar solvent than NaCl. in CF2 double bond C double bond CF2 molecule, all the 4 fluorine atoms are in the same state. Like, can you give me the options of this question? Like, this is all a fact only, okay? So just give me the answer for the question. Give me the answer for the question. Get the answers. Okay, A and C got like answer. A and C. Okay, so we'll check the answer. The first one is CaO2 is less stable than MgO2. CaO2 is less stable than MgO2. Can I write it as like Ca2 plus 2O, O2 minus 2 times of O2 minus. And this is like Mg. 2 times of like more stable. CaO2 is less stable than MgO2. Is it true or not? See, this is going to be like a more ionic in nature. Yes. And this one has few covalent character in it. It has covalent. Yes. So the less covalent character in MgO2. The less covalent character is in MgO2 or calcium O2. Sorry. So what is the, according to Fejan's rule, what is, how will you calculate the covalent character? It is when the size of cation should be small and the size of anion is large. Anion is large. Now compare like magnesium and oxygen. So oxygen is small in size. Okay, oxygen is small in size in both the cases. Now when you compare this one, this cation is going to be small and this cation is going to be like large. So which is going to be like more stable when the size of cation is small. So MgO2 is going to be like more stable than CO2. So therefore, it is given as less stable. This one is incorrect. Now, Ka2 of fumaric acid is more than the Ka2 of malic acid. Okay. So now tell me like what is fumaric acid and what is malic acid? It is cis and trans isomer, you know. Okay. So C double bond C, COH, COH. It is a dicarboxylic acid. So C double bond C, COH, COOH, hydrogen, hydrogen. So which is like malic? This is malic acid and this is fumaric acid. So Ka of fumaric acid is more than Ka of malic acid. Is it true? See here, the COH is at the trans position. Is it at the trans position? Okay. So therefore, here it is like at the cis position. At the cis position. So here there will be like steric. Here there will be like steric repulsion high. Okay, steric repulsion high, and this is going to be less stable. And here it is going to be like more stable because the bulky groups are present at the opposite side. So the Ka of which one will be more? That is, what is like Ka? Ka is nothing but the acidity. The acidity, yes. So if here you can see like hydrogen are just at the opposite position. Here COH, your it is the, I'm talking about the acidity of COH. Okay, this one. This one. Okay, so Ka of which acid is going to be like more? So this one is going to be more because when you replace the hydrogen, okay, you'll be getting, we know that the more strong acid is due to the strong conjugate base. Conjugate base. So if you write the conjugate base, you will be removing hydrogen over here. Okay, so CO minus, CO minus. And here it will be like CO minus, CO minus. Now we know that among cis and trans, which is more stable, cis isomer or trans isomer, which is more stable, cis isomer or trans isomer? Which is more stable? Trans is more stable. Yes, trans is more stable. So therefore, the Ka of fumaric acid is more than the Ka of maleic acid, which is now LiCl is less soluble in polar solvent than NaCl. LiCl is less soluble in polar solvent than NaCl. Is it true or false? Is it true or false? So now again, when you consider like this one is more in size compared to this one, so it has like more covalent nature, more covalent nature. Okay, so therefore it is less soluble in polar solvent. It is true. In CF2, double bond C, double bond CF2, do all the fluorine molecules lie in the same way? This is like allenes, okay? So in allenes, when you take, like you'll be having orbitals over here for the overlapping, okay? So now if this overlap like this, now the second overlapping will be just perpendicular. So therefore, like one is parallel, the other one is perpendicular. So they are not lying on the same plane. Okay, in CF2, double bond C, double bond CF2, they won't lie in the same plane. So this is also wrong. So option B and C are the correct answers. Got this question, everyone? Got this question? Clear with this question? Yes. Moving to the next question. Yes. So the next question is, which of the following characteristics are of thermosetting plastics? Which of the following are characteristics of thermosetting plastics? Heavily branched cross-linked polymers, linear, slightly branched long-chain molecules, becomes infusible on molding, so cannot be reused, softened on heating and hardened on cooling, it can be reused. So therefore, which one is going to be like the correct one? Which is the correct answer? Like choose the answers. Which is the correct answer? Thermosetting plastics, thermosetting polymers. Okay, so I'll give you the answer. Shall I give you? Like it is a heavily branched cross-linked polymers. It is true. Okay, slightly branched is wrong and becomes infusible on molding, so it cannot be reused. Okay, so when you like do thermosetting, you're setting the polymer using like what is thermo is heat. Okay, so it cannot be reused, and it softens on heating and harden on cooling. It can be reused as well. So A and C are the right answer. Okay, fine. Next is mixture of pH, CHO, okay, and HCHO is treated with NaOH, then Cannizzaro reaction involves. Okay, so like what is Cannizzaro reaction? Cannizzaro reaction is where both the oxidation and reduction takes place. Reduction takes place. Now, oxidation of HCHO reduction. Okay, they have just asked like which one gets oxidized and which one gets reduced. When you know like which gets oxidized and which gets reduced, then you can solve this thing easily. Which aldehyde gets oxidized here and which aldehyde gets reduced. Okay, using this, solve the question and give me the answer. Solve the question and give me the answer. Which will get oxidized and which will get reduced. Like when you do it, you'll be getting acid, that is salt of acid, okay, and alcohol. And alcohol as the product. We know that right? Carbonyl compounds on oxidation gives acid and in reduction gives alcohol. Okay, so which will produce the acid and which will give the alcohol? When you have like PHCHO double bond OH. Okay. So the condition for the Cannizzaro reaction is there should be no alpha hydrogen. Yeah, there is like no alpha hydrogen. But when I take like formaldehyde, it has a alpha hydrogen. It has an alpha hydrogen. Okay. So now anyone should not have the alpha hydrogen. So here benzaldehyde doesn't have the alpha hydrogen. So the one which has the alpha hydrogen will undergo like oxidation because we know that alpha hydrogen are acidic in nature. Yes, they are acidic in nature. We have done it in the first question itself. Alpha hydrogen are acidic in nature. So it can move out. And we know that the removal of hydrogen is oxidation. Removal of hydrogen is oxidation. So oxidation takes place at the formaldehyde because it has hydrogen are more acidic because you have a carbonyl group over here. It can withdraw the electron. Therefore, it will undergo oxidation. So oxidation of HCHO is right. It means that PHCHO will not undergo oxidation. So what happens to the PHCHO? It will undergo the reduction. And here, which transfer, hydrate transfer takes at HCHO is it is true, right? It can move out. So therefore, it is also true. So option A, B, D are correct answers. Got this question, everyone? Got this question? Clear with this question? Yes. Moving to the next question. If the radius of first orbit of X of the following is the correct conclusion. The de Broglie wavelength in the third Bohr orbit of hydrogen is 6 pi x. Okay, so we know that de Broglie wavelength n lambda pi r 2 pi r. So here the radius is given as x, so I'm taking r as x. R is x. Okay, so the de Broglie wavelength in the third Bohr orbit. Third Bohr orbit means you will be putting the n value as 3. So 3 times of lambda is equal to 2 pi x. 2 pi x. Okay, 3 times of lambda is equal to 2 pi x. So therefore, and here they have given like what will be the de Broglie wavelength in the third Bohr orbit of hydrogen atom. Okay, so therefore it will be equal to just multiply this nx. Okay, put nx over here, like make it as nx. So I'll be getting like into 3. Yes, if I put n value over here, so it will be equal to 6 pi. So this is right. The second Bohr radius of helium ion is 8x. Does the second Bohr radius of helium plus ion is 8x? Does the second Bohr radius of helium plus ion is 8 times of x? How will you calculate the Bohr radius? What is the formula for the calculation of Bohr radius? Rn is equal to, what is the formula to calculate the radius of second Bohr radius of helium plus ion? What is the formula to calculate the Bohr radius? Can you able to hear me? Yes. Can you able to hear me? Am I audible to everyone? Is my screen visible? Is my screen visible? Okay, voice is breaking. Fine, fine, fine. So we'll close with this question. See, you have to calculate the Bohr radius. Okay, you know the formula for the calculation of Bohr radius. What is the formula for calculation of Bohr radius? What is the formula to calculate Bohr radius? Is A naught into Z square. Yes. So here, like helium plus ion is here. Helium's Z value, and they have given you the second, it is like N value is 2. Okay. So if you do this, like you won't get it as like index. So the de Broglie wavelength in the third Bohr orbit of lithium 2 plus is equal to 2 pi x. Lithium 2 plus. Okay. So lithium 2 plus is equal to 2 pi x. Is it true? For lithium, what is Z value? Z value is going to be like 3. Okay, so de Broglie wavelength in third Bohr orbit of lithium 2 plus is equal to 2 pi x. Is it equal to like 2 pi x? And lambda is equal to 2 pi r. 2 pi r. Okay, so when I put like it is x, so if the radius of first orbit of hydrogen atom is x. Okay, it is like for first orbit of hydrogen atom is x. So when you equate this one, okay, so for hydrogen atom they have given, you should do it for the lithium atom. For lithium atom, what is Z value? Z value is 3, okay, Z value is 3. So when you like divide it by 3, you'll be getting 2 pi x. So which is also like true. And the second Bohr radius for beryllium 2 plus is equal to x. So again, we know that Z is equal to 4 and N equal to 2. So when you substitute, like, will you get it as x? No, you won't get it, right? So this is wrong. So option A and C are the right answer. Option A and C are the right answer. Got this question, everyone? Got this question, everyone? Okay, so with this question, I'll end the class. And in tomorrow's class, like we will solve the question based on coordination chemistry. As last class, we had network issues, so we'll solve the coordination chemistry in the next class. And after tomorrow, we'll solve both GOC and hydrocarbon question. Okay, so just go through coordination chapter and join back tomorrow. Okay, thank you all. Thank you. Bye bye. I'll post the notes in the group. Okay, today's notes, I'll post it in the enable group. Are you there in enable group? If not, just send me the number. I'll send you the invite link to join the group. Else I'll add you in the group. If you are in the enable group, I'll be sending the notes daily. After the class, I'll be sending the class notes. Okay, and I'll know this number and I'll make you to join the group. Okay. Okay, bye bye. Thank you.